Hello, welcome back to another pre-recorded video. Hooray. Anyways, I am going to do another universe sandbox video. Last time we made all the planets 2 times bigger until everything went its own way. And we ended off with the game crashing. So, I'm gonna do another one where I'm going to make a planet as hot as I possibly can. But first I'm gonna do a quick one where I double the sun's radius every time. Begin. No, it's unlocked. ×2. Boom. Oh, that went fast. Everything's elliptical. Oh, here comes the asteroid belt. Mercury's somehow surviving this. And Jupiter coming in. Is every single planet gonna be like this? Yeah, it is. Alright, I just hope Quoror survives. Alright, so sun. Again. Time to another 2. Well, that ended quick. So the entirety of the inner solar system is now gone. That is wonderful. How hot is Uranus? Uranus still isn't hot. Will Uranus ever get hot? Whoa! How the heck did this happen? It's over 1,000 degrees Celsius on both planets. And somehow, they're orbiting the sun like this. Peace? I can't have that here. There we go. And yep, there goes Ceres. So, Saturn and Jupiter's gone. Uranus and Neptune and Pluto's gone. Will Quoror survive? No! Well, it survived, but it's just flinged out now. That's not Quoror. No, not Quoror. No. Alright, our last chances are Eris and Sedna. Will either of them do it? Now, no. Oh, yep. Oh my goodness, Venus came back. Let's try and save the solar system. 64. Some of them are starting to come back in. 128. 256. 512. Now it's a black hole, I don't care. 1024, 2048, 409, 6819, 16384, 32768, 65536. 1310722621144. 500,000 and something and 1,000,000 something. I have no idea why I did this, but I did. Alright. Now for the main focus of the video. So, now I'm going to load. So yeah. While it's loading, I'm just gonna tell you to like and subscribe. Alright. So, let's start with the sun here. Now, rule 1 is closeness. So let's have an Earth here and an Earth here. And also an Earth right out here for no reason. Alright, I don't know why I did that. I know why I did it. It was a misclick. Right, begin. Alright, so the planets are orbiting. Wait, I can turn on orbits. Because there's not 20 bazillion things. That's crazy. So, yeah. But I still prefer trails. And just speed up. And let's do it for 5 years. And that's about 5 years. So which one was closer? This one got to about 2,274 degrees Celsius. This one got to about 2,072 degrees Celsius. So this one's hotter. So something interesting is going to be composition. Iron is liquid level. Silicate is solid/liquid level. And water has now become plasma. That is pretty cool. So, I'm gonna go back into it. Have an Earth out here. Have a Mercury just out there, and then have a Venus all the way out here. Now, which one do you think is going to be hotter by the end? Yeah, I hate when that happens sometimes for some reason, and I don't know why. Alright. So, see these two getting warm, and also Venus getting warm too. And it's been 20 years. Let's check in on them. The one I think will be the least is Earth, even though it's closest. It's 2759. But same stats. Mercury is 2382. No, Mercury was more. It was not more, actually. It was less. I'm an idiot. So, same stats. If I try to put on water, yeah, it would be plasma. Hydrogen would be gas. And then Venus. Venus is 2,249, which is still not as much as the Earth, but from out here, that is insane. See how far out it is. Like, imagine Venus being here. Pause go to 25 years. I'm expecting it to be in the 3,000s. 5,000s. Okay, so now let's just... It's because of the greenhouse effect. Let me just pause and show you what the greenhouse effect is. Yep, this channel's educational now. Click the link at the top of the screen or something to see Dr. Dean another educational video. So it happens, so on surface I think it is, you can change atmosphere. It's 93 the atmosphere mass of the Earth, even though it being slightly smaller than the Earth. So it heats up, and from here it gets to around 3,500. And that is pretty cool. Well, It's pretty hot, actually. So let's just advance it to exactly 100 years. Alright, great. So I'm thinking, I'm just gonna take Venus here. Put one like here, put one like there. Alright. And just go to surface. Oh. Well. Anyways, let's go to atmosphere. Let's give it 1 Earth, 10 Earth, 100 Earth, 1,000 Earth, 100,000. Let's just do 100,000 Earth atmospheres for Venus. That seems good. Now, how long does it take to orbit? Average temp is TA number? No. Please don't be TA number. Alright, so orbital period 6.14 hours. Alright, so let's slow it way down to 1 hour a second. Perfect. Now let's watch from Venus's POV. I think I'll have to go to surface and see it from there. 85.5. Alright. It's starting to get hotter, so 2, 4. So let's keep it at a nice 4. So I don't know why it's glitching out, but the minimum temperature is getting warmer and the maximum temperature is too. And this is all happening in the lapse of 8 hours per second. That's crazy. Let's actually make it 1 day per second and see what happens. Like this, boom, oh my gosh, I'm gonna have a seizure. It's up to 3,000. It's in the 3,000s. 10 days a second. Alright, let's just speed it up super fast. Max temperature nearly at 10,000. Oh my goodness. Oh my goodness. Oh my goodness. Is max temperature gonna reach 10K? It's topping in around 9,800. Pause. Alright, let's see composition. Solid, gas / plasma. It's not quite plasma yet. And gas. I'm confused on why completely though. Because, I mean, greenhouse effect. Maybe the sun sucked up all of its atmosphere. Oh, misclick. Damn it, I hate misclicks. So, okay, so about here, so orbit's alright, but what if I give it a massive atmosphere? So 1, no, 10, 100, 1,000, 10,000, 100,000, million. Let's stick with a million. Oh. Yeah. Forgot how fast it was going as well. Okay, so it orbits every 2 days. So let's set it to 1 day a second. Right. So let's look at the average here. So it's alright. The average is increasing. Let's just check its max because that's what I did last time. 6. Alright, let's go times 2 on that. There's a whole orbit in 1 second here. Alright, so this is just using the greenhouse effect, really. And this is already that much. So let's speed it up 20 times. Oh my goodness, it's turning a starish color. This orbit. Whoa! What the heck is happening here? Now this orbit is pretty far out, so probably not gonna be, you know, the most hot. But what if I put the orbit in more? There we go. Alright, not too in. Now I've done this before, and last time it had the sun completely engulf the atmosphere and the sun turned blue. That is crazy. Alright, so surface, I'm going to go to atmosphere. Let's set it to 100,000, 10,000, 100,000, million. Alright. So, 1 day a second. Alright. So, how fast does it orbit? It orbits every 12 hours. Alright, so it's gonna orbit twice in 1 second. With that much atmosphere, it's getting hot quickly. Oh my goodness. That is insanely fast. Alright, let's times 10 the speed. 10, 100, it's getting 5,000. It was up in the 5,000s. Oh, now it's cooling off. So let's check surface. And no, it hasn't. Wow. Alright, so it's maxing out around 6,885. So I'm gonna do one more test with that. Actually, no. Let's go on to the next thing. So one thing I think will help it is so I'm just gonna show you for a sec. I'm just gonna put Jupiter super duper far out. Oh, that's what happened to the Earth and Mercury. Oh. I guess that. Oh yeah, I think they got blasted out by Venus's existence. So it can turn up the mass. But I think it'll have to be on pause for this. Pause. So let's just speed it up. Now it's pretty hot. And now I'm not a scientist, but I think it's nuclear fusion. Yeah, that's basically a planet becoming a star. Doesn't happen really when I just set up the radius and nothing else. But gonna turn down the radius. Do if I just keep turning down the radius? So, alright. So, let's see how hot we can get it only from nuclear fusion. Alright, so let's try. Sorry, 75 I know is a star. Is not a star, I mean. 76 works. 77 works. Alright, let's try 78. 79 Jupiters. And that's the cutoff. Alright, so let's try the most we can. Alright, so this is probably where nuclear fusion is going to be at its first. 0.1. I don't want. No. 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 Now. 0.2. That works. 0.3. That works. Let's try 0.5. 0.5. Let's try 0.4. 0.4 works. Does 0.45. No. Doesn't. 4999. Yeah, it just rounds up. I thought I was on to something, but no. So it can get up to 78.4. And that is max nuclear fusion, I think. Oh. So I thought if I put it down, pressure would equal hotness. But no, it doesn't. Whoa. So whoa, what are those? Can I? Whoa! I mean, I don't think I'd count that, honestly. So that just lowers temperature. Because, you know, I guess that makes sense since it's turning into a black hole. Alright, let's just wait. Oh, I'm raising the temperature, not the radius. Maybe that was why. Am I an idiot? Probably. Maybe that turns condenses Jupiter. Alright.